Good day! So let's formalize yung diniscuss natin dun sa previous video on the general antiderivative of f of x, specifically yung notation natin. If capital f of x plus c is the general antiderivative of f of x, we can write yung notation using our notation that the general antiderivative of lowercase f of x is equal to capital F of x plus c. Let's take a look at some theorems that will be useful for us. Actually, ginamit na natin yung iba dito before, pero i-formalize na lang natin, so mas formally natin siya magagamit sa next videos natin. So, some theorems on antidifferentiation. First is yung general antiderivative of dx. Parang wala tayong kinukuhanan ng general antiderivative, pero ang tingin natin sa kanya ay may 1 na nandun, hindi lang natin na-indicate ng maayos. So, if we see yung parang antiderivative tapos dx agad, there is an implied 1 sa loob. And the general antiderivative of 1, like ano bang function magkakaderivative ng 1? That will be x. So again, the general antiderivative of dx or antiderivative of 1 is equal to x plus our constant of integration, x plus c. For our second case, ginamit rin natin before, if you want to take the general antiderivative of k times a function, pwede nating ilabas yung k at unahin muna yung paghanap sa general antiderivative ng function. Then, you just multiply k afterwards. Remember that k here is a constant. For our third rule, the general antiderivative of a sum is equal to the sum of the general antiderivatives of the terms nung ina-add natin. This is similar, when you take the derivatives of sums, pwede mo siyang i-evaluate as the sum of the derivatives of the terms. Generalizing rules 2 and 3, we could say that the general antiderivative of a set of terms composed of a constant times a function, so constant function plus constant function plus ... plus constant times a function, pwede natin siyang i-rewrite na constant times the antiderivative of a function. Kumbaga, dinistribute muna natin yung antiderivatives to all the terms, and then if they have constant coefficients, pwede natin siyang ilabas dun sa respective antiderivatives nila. Now, for our fifth rule, if we have an n which is a rational number, then the general antiderivative of x raised to n. So, ito na yung power rule. I-formalize natin to incorporate both cases. So, yung first case, gagamitin natin yung direct na power rule, na x raised to n plus 1 all over n plus 1. Kasi nga, if you take the derivative of x raised to n plus 1 over n plus 1, mag-subtract ka ng 1 dun sa power, gagawin mong coefficient yung n plus 1, magka-cancel siya dun sa n plus 1 sa denominator, you will go back to x raised to n. But this is only applicable if your n is not equal to negative 1. Nakalimutan ko yung plus c, so isama natin siya dun. So if n is equal to negative 1, you are taking the antiderivative of 1 over x or x raised to negative 1. So ang function na derivative niya ay si 1 over x, I see the natural logarithm, si ln. So, the general antiderivative of x raised to negative 1 or 1 over x is ln of the absolute value of x plus our constant of integration. Now, I just need to highlight this because this is very important, that these rules do not extend to the product of functions. When you want to take the general antiderivative of the product of functions, hindi mo i-distribute yung general antiderivative. This is not the same as the product of the general antiderivatives of the factors. So, no. Again, hindi natin pwedeng kunin yung general antiderivative ng product by taking the individual antiderivatives of the factors at imumultiply natin. Mali yun. Mali. We could extend that dun sa general antiderivative naman ng fractions, ng quotients. Hindi din pwedeng sabihin na if you want to take the general antiderivative of f over g, ay kukunin ko muna yung antiderivative ni f, i-divide ko na antiderivative ni g. Mali. No. X. Takot tayo dyan. So, we do not distribute antidifferentiation sa products or sa quotients. Hindi rin naman natin siya ginagawa sa derivatives, sa differentiation. So, hindi rin natin siya dapat gagawin sa anti-differentiation. So, after going through these rules, let's take a look at some examples na ina-apply natin tong rules na to sa algebraic functions, mga x raised to a power. Let's take a look at some examples using yung theorems na ginamit natin. Let's start with our first problem. We want to find the antiderivative of 7x squared minus 3x plus 1. So first, apply natin yung rule natin na pwede nating ilabas lahat ng coefficients. Tapos, pwede nating i-take yung individual terms as separate antiderivatives. So we'll rewrite our expression as 7 times the antiderivative of x squared minus 3 times the antiderivative of x plus the antiderivative of dx, or the antiderivative of 1. This will be equal to 7 times x cubed over 3 plus c1 minus 3 times x squared over 2 plus c2 plus x plus c3. Distributing the factors and grouping yung mga x's together, we have 7 over 3 x cubed minus 3 halves x squared plus x plus 7c1 minus 3c2 plus c3. But again, as we have seen sa earlier problem, we could treat yung combination ng constants, kasi lahat to constants, as a single constant, and rewrite yung answer natin as 7 over 3 x cubed minus 3 halves x squared plus x plus isang constant na lang, plus c. And we highlight our final answer with a box. Let's move on to the next item. Now we'll look at the antiderivative of 5t squared minus 2t plus 3 all over the cube root of t. So I'll just change the variable from x to t. Take note na yung dx magiging dt kasi ang variable natin ay t na, hindi na x. So my first step will be to rewrite yung cube root of t as t raised to 1/3 at i-distribute ko siya sa lahat ng terms. So I will have 5t squared all over t raised to 1/3 minus 2t over t raised to 1/3 plus 3 over t raised to 1/3. In general antiderivative nun. Then we'll apply the rule that we applied sa previous problem. Yung mga constant coefficients pwede nating ilabas. At i-treat natin yung individual terms as individual antiderivatives. Kumbaga, dinistribute natin yung process ng general antidifferentiation. Then we'll just take the general antiderivative of each term. So we'll get 5 times t raised to 8/3 over 8/3 minus 2 times t raised to 5/3 over 5/3 plus 3 raised to 2/3 all over 2/3 plus our constant of integration. And, just simplify this, you'll get 15 over 8 t raised to 8/3 minus 6 over 5 t raised to 5/3 plus 9 over 2 t raised to 2/3 plus the constant of integration. This should be our final answer. We highlight this with a box. You are free to pause this and check kung tama yung sagot. Pero I think okay na tayo for now. Okay, let's move on to our next item. We want to find the general antiderivative of 1 over x cubed minus 2 over x squared plus 3 over x. Our approach will be to rewrite lahat ng x sa denominator as x raised to an exponent kahit negative. So we could write this as the general antiderivative of x raised to negative 1/3. Isi-split ko na rin, i-distribute ko na rin yung process of general antidifferentiation. So general antiderivative of x raised to negative 3 minus 2 times the general antiderivative of x raised to negative 2 plus 3 times the general antiderivative of x raised to negative 1. Evaluating each antiderivative, I will get x raised to negative 2 over 2 minus 2 times x raised to negative 1 over negative 1. Then again, ang general antiderivative ng x raised to negative 1 is ln of the absolute value of x. So that will be 3 times ln of the absolute value of x plus our constant of integration. All that's left is to simplify the expression, and we'll get negative 1 over 2x squared plus 2 over x plus 3 times ln of the absolute value of x plus c. And let's just highlight this with a box to indicate na siya na yung final answer natin. So for this set of examples, we took the general antiderivatives of algebraic functions. In our next video on the same topic, we'll take a look at the general antiderivatives of some transcendental and trigonometric functions. So see you sa next video at salamat sa pakikinig.